All right, so in this video lesson, we are going to look at all different properties of quadrilaterals. We did parallelograms yesterday. You should have this family tree available to you. And let me actually make this a little clearer. I don't think that made it any better, but we'll pretend. So I'm going to use this sheet. Mostly we're going to be talking about parallelogram, rhombus, rectangle, and square. These are kind of just extra. But we're going to kind of classify this in our notes again using a checkmark table to make it a little bit easier to look at. But this is your family tree, which you have access to. So taking those notes, and let me zoom in a little bit. Taking those notes and taking our information and kind of checking off what they follow. A square obviously is all of these. A rhombus is super close to a square. It's just smushed a little bit. But we're going to use these pieces of information to answer the rest of these questions. So for number 2, A and B, we know both of these are parallelograms. And our goal is to find A, B, X, and Y. Now, of course, don't forget you do have access to your calculator should you need it. So these go back to yesterday. So B is going to be the same as the side opposite from it. So this is going to be 10. Same thing with A. Y and its opposite angle are going to be congruent. So this would be 62 degrees. And then my interior angles here that are next to each other are going to be 180. So 180 minus 62 gives me, oh Lord, excuse me. Oh my Lanta, I am so sorry. So X would be 118 degrees. All right, now looking at part B, my opposite sides are the same. So this is going to be 15 and this is going to be 8. X will be 100. Since it's across from the 100-degree angle, they are congruent. Now 30 and Y have to add up to make these 3 angles here 180. So this whole angle here is going to be 80 degrees. So I'm doing 80 minus 30 here. And that's going to give me a Y value of 50. All right. So here we go. We have measure of angle 1 is 25 degrees. So one thing I know, since this is a rhombus, the diagonals are perpendicular. So I know this is a 90-degree angle. So angle 5 is 90 degrees. So angle 1 is 25. That means angle 2 also needs to be 25 because the diagonals bisect the angles. So angle 2, not comma, is also 25. Now to find angle 3, since this is a triangle, I'm going to do 180 minus 90 minus 25. So angle 3 is 65, which means angle 4 is also 65. So I could continue filling this in. So 1 and 2 here are both 25. That means both of these here are 25. These are both 65, so these are both 65. And all 4 of these here are 90. All right, SL is 10. So SL is 10. MT is 10 because they're all, those are my opposite sides. But the really nice thing about a rhombus is that all of the sides are congruent. Oh, they labeled this TM, not MT. My apologies. So I know LT is also 10, and I know S. Lord have mercy. Can't write today. So I know all the sides are 10. All right. Kicking it up a notch. Quadrilateral flat is a rectangle, and our diagonals are intersecting at O. So I need to find the measures of 1, 2, 3, and 4. Well, looking back over here, under rectangle, I have that all angles are congruent. So that tells me that if angle 1 is, oh, I already have that written down here. If angle 1 is 18, then this angle up here would also be 18. So my corners make 90 degrees. So 90 minus 18 tells me that 4 should be 72. All right, so we have angle 4 being 72. Now to find 2 and 3. Since our diagonals bisect each other, I can put tick marks on all corners or all of my diagonal sections that meet at O. I have just created 4 isosceles triangles. And in isosceles triangles, our base angles are the same. So that means that 2 is also 18. And that means that 3 is also 72. Now we could also, using the triangle sum theorem, we could find these angles. I could find those angles. I could also find these angles in these corners by using what we've done over here. So I could, just by knowing this one angle, find all of the angles inside of my rectangle. All right. So FA is 27. FA is my whole diagonal. Okay. They want us to find LO. They want to find just this part of my diagonal. Well, since my diagonals are congruent, I know that FA is the same as LT. So I know that LT is also 27. And I know that O cuts that in half. So if I divide that in 2, that tells me what LO, FO, OT, and OA all are 13.5 because they're all congruent. All right, now we have a square. We have squares, a square with diagonals intersecting at E. I know that these are congruent. I know these outsides are all congruent. I know that these angles are all congruent. I also know that every angle is 90 degrees. Now let me rephrase. This full angle here, angle ABC, angle BCD, angle CDA, and angle DAB, all my big angle corners are right angles. And I'm going to actually tweak this because my diagonals here intersect at perpendicular angles. And then all of my smaller angles in here are all congruent. So BAE, EAD, ADE, EDC, and so on. They're all 45 degrees. So my angles are either going to be 90 or 45. All right. AB is 6 radical 2. And I have to find the lengths of BC and BE. Well, I know BC is also 6 radical 2. Now, I need you to think way back in your brain to when we did special right triangles, when we did 45, 45, 90s. Because I have a 45, 45, 90 degree triangle. So when we have a 45, 45, 90, this was A, and A radical 2. We did not just teach you special right triangles because we thought it would be fun. We taught you special right triangles because we knew one day you were going to need it. So BE is this A value here because this is the hypotenuse, which is on the outside of my square. So BE is 6. All right. Trapezoid. You have one set of sides that are parallel, and it's these two here. So I need to find the measures of angles R and P. Well, I know since these two lines are parallel, that 110 and whatever angle PR need to add up to 180. So angle P has to be 70 degrees. So you can also think of the sum of the interior angles here. So all 4 of these things added together need to make 360. So I can do 360 minus 110 minus 70 minus 84 and get 96. Or, the degree symbol. Since RA and PT, since these are parallel, I can think of the angle theorem here where these two also need to add up to 180. And 180 minus 84 also gives me 96. So either way you slice it or dice it, you're getting 96 for this one and 70 for that one. And if you add 96, 84, 70, and 110, they all give you 180.